Hey guys, this is Unit 6, Day 2, and this is over area and perimeter problems. So we're going to start with our warm-up that dealt with what we covered last class, which was Pythagorean theorem, and we did a little bit of area, but mainly it was just using Pythagorean theorem to find missing sides. All right, so number 1, it says, look at the figure below. If side AD, or the distance from A to D, is 9.5 inches, so label that on your diagram, and the distance from D to C is 3.2 inches, obviously not drawn to scale, and side B to C is 6 inches. Ooh, that B is supposed to be way over here, so FYI. All right, B to C is 6 inches. And what is the area to the nearest square inch of triangle ABC? All right, so remember for area, I just want to remind you, area of a triangle is 1/2 base times height, where the base and the height make 90-degree angles. So this is your height, this is your base. From A to C is your base, B to D is your height, because we're trying to find the area of this triangle ABC. All right, so what we need to know is, what is the base and the height? So I know this whole base is going to be that 3.2 plus that 9.5. So base equals 3.2 plus that 9.5, because that's this part plus this part to give you that whole base. Add those together and we get 12.7. So that side is 12.7. And then, so we've got our base, now we need to get our height. So I can use this triangle, triangle BCD. Let me scooch my finger over. Triangle BCD, I know 2 of the sides of this right triangle. So I can find the third side using the Pythagorean theorem. Once I know that third side, that's going to be my height for my big triangle ABC. So this is my C side. I can call this A and this B if I wanted. I could have switched those as well. All right, so use the Pythagorean theorem, which is A squared plus B squared equals C squared. And remember, your C side is always your hypotenuse side, the side across from the 90-degree angle. Plug in your numbers, and we've got 3.2 for our A, square that, plus B squared, because we don't know what that is yet, is equal to 6 squared, because 6 is our C side. 3.2 squared gives me 1.0, no, that's not right. 3.2 times 3.2 gives me 10.24, plus our B squared equals 36, because 6 squared gives me 36. And then to get that B squared by itself, we're going to have to subtract 10.24 from both sides. And I get 25.76. And then last but not least, take the square root of both sides. And we get 5.07. We'll round that to 5.1. All right, so this height of the triangle, which is the leg of this right triangle that we just found, is 5.1. So now we've got our base, we've got our height, we can find the area. So area equals 1/2 times the base, which we just found out was 12.7, times the height, which we just discovered was 5.1. So in my calculator, I can type it in parentheses 1 divided by 2 to get the 1/2, times 12.7 times 5.1. We get 32.385, so we'll round that to 32.4. And all these units were inches, and area is inches squared, so our answer is 32.4 inches squared. All right. If you look at my key on it's learning, it's going to be wrong. I made an error in where I put my decimal on this one. So this is the correct answer. So if you have friends in the classroom that are not watching this video or just getting the notes from It's Learning, you might mention that to them. All right, next one. If if the distance from A to B equals the distance from B to C, boom, boom, then what is BC in units? Good question. All right, so if we don't know what those sides are, but we do know they're equal, what do? Give them a variable. So they're both x. Now we still use Pythagorean theorem. A squared plus b squared equals c squared. And in this case, my c side is the side that has the 8. These are my a and b. I'm replacing those a and b with x's. So that's x squared plus x squared equals 8 squared. Now when you add x squared plus x squared, think of it as having a 1 in front of it. So we got 1x squared plus 1x squared gives me 2x squareds. And 8 squared gives me 64. Now you got to work towards getting those x squareds by themselves. Since it's 2 times x squared, divide by 2. You get x squared equals 64 divided by 2 is 32. And then take the square root of both sides. We get x equals 5.7 when I round to the nearest tenth. And they didn't tell me, they just said it's units, so units. All right, and there's your warm-up. So that's a little review, a little bit challenging questions. These would be great test questions, FYI, or quiz questions of what we learned last class. All right, next page is a good reference sheet telling you all kinds of formulas. We got area of a square is side squared, perimeter of a square. I never memorize perimeter equations or formulas because perimeter is just always adding up all the sides. So as long as you just add up all the sides, you've got your perimeter. Area of a rectangle, length times width. We got our Pythagorean theorem, which only works with the right triangle. And remember, the side opposite your right angle is your C side. Doesn't matter which ones you put for A and B on the legs, but your C side has to be the hypotenuse. And that's a squared plus b squared equals c squared. We've got the area of a triangle is 1/2 times base times height, where the base and height meet at a 90-degree angle. Area of a parallelogram, base times height. Again, base times height have to meet at a 90-degree angle. We've got a kite. The area is 1/2 times the diameter 1 times the diameter 2. So you got your two diameters. You take diameter 1 times diameter 2 and take half of that. For a rhombus, area is, it's at an angle, 1/2 times the diameter of diameter 1 and diameter 2. So just like a kite, same formula. Multiply your diameters together and then divide by 2 or multiply by 1/2. And then trapezoid is 1/2 times the number that you get when you add the two bases together. Remember, your bases are always the two sides that are parallel to each other. Okay, and then your height meets at a 90-degree angle to your bases. So you might want to add that to your reference sheet there. All right, so there's all your formulas that you're going to be using. Let's work some problems. Okay, it says a rectangular floor 3 feet by 8 feet will be completely covered with square tiles that have a side length of 4 inches. How many square tiles will it take to completely cover the floor? All right, so some things you want to consider. Are all the measurements in the same units? In this case, we've got feet, and inches. So no, they're not. Are you concerned with the side length of the square tiles? So the square tiles, they said, had a side length of 4 inches. So we are going to need to either convert that to feet or convert our feet to inches so that they're all the same. And with a square tile, if a side length is 4 inches, it is a square tile. Since it's square, then that means this is 4 inches and this is 4 inches. Okay, so understand all the sides of the square are the same. And then what unit of measure or label should your answer be in? They're asking how many square tiles it will take to completely cover the floor. So since they're asking for a number of tiles, we're not going to have any units attached to that. It'll just be how many tiles we're getting. So instead of putting units attached to it, like, oh, this many feet, this many inches, or anything like that, our answer will actually be this many tiles. Okay? All right, let's start to figure this out. So I always need a diagram. So we've got a rectangular floor, and it's 3 feet by 8 feet. I'm going to go ahead and convert those to inches. So 3 feet, the way we make that into inches, it's 3 times 12, because there's 12 inches per foot. So that gives me 36 inches. So we've got 36 inches for one side. And then the other side was 8 feet. 8 feet, I just take 8 times 12 to get how many inches that would be. And off the top of my head, that gives me 96 inches. So this side is 96 inches, which was the same as 8 feet. All right, so we've got those in inches. And then we've got our tile, which is 4 inches by 4 inches. So the way we can figure out how many tiles it's going to take to tile this floor is I can find the area of the rectangle, and I can find the area of one tile, and just take the area of the rectangle divided by the area of the tile. That's one way we could do it. There's multiple ways we could do that. Or I could see, well, how many times does 4 inches fit into this 96 inches? So I could do 96 divided by 4 to tell me how many tiles go across that way. And I get 24. So it will take 24 tiles going this way. And then I got to figure out, well, then how many tiles do I need going up? So 36 inches divided by 4, because 36 inches this way, each one of these tiles is 4 inches tall. So 36 divided by 4 gives me 9. So it'll go 9 tiles going up that way. And then I can find the area. How many tiles to cover the whole area is just length times width. So the number of tiles equals 24 tiles times 9 tiles, which gives me 216 tiles. So that's one way you could have done it. Another way, and the reason I like this way is because I need to know exactly how many tiles go across, because it could have not worked out properly. It could have been like 24 and a half tiles, and that would have been tricky. But I'm glad it works out to where it's just perfect amount of tiles this way, perfect amount of tiles going up that way. So we get a nice whole number. So we're not saying, oh, 24 and a third of a tile or anything like that. So this is the way I prefer to do this problem. The other way I was thinking of might not have got us that legit answer. And that would have been figuring out the area of the rectangle, the area of a single tile, and then take the area of the rectangle divided by the area of a tile. But I don't trust that way as much. Just in case you run into, well, it takes 24 and a half tiles going this way and 9 and a half that way. We'll try to mainly work with just whole numbers and make it to where it works out nicely for this. All right, let's do another one. Says Edgewood wants to build a new community pool for the summer. The pool is going to be a trapezoid shape surrounded by grass. So here you've got your pool, and then out here around the pool is our grass. Okay, we're making a trapezoid shaped pool, and they want to know what is the area of the pool. So we got to find the area of a trapezoid. Area of a trapezoid was, if you look back at your reference sheet, because I don't expect you guys to memorize these. I will have this reference sheet for you when we quiz and when we test. But the area of a trapezoid is 1/2 times the number we get when we add the two bases together times the height. So I like to write my formulas in my work so then I can just fill in those bases and heights with what I know they are. So 1/2 times base 1 plus base 2 times the height. So remember, your bases are your two parallel sides, okay? So in here, they're telling us, oh, this is important right here. If you didn't notice this, the scale, each one of those squares is 4 square feet. Now, if I remember correctly in the past, my students have missed this question on a quiz or a test because they didn't pay attention to the scale. So each one of these squares is 4 feet. So this is 4 feet, that's 4 feet, that's 4 feet, all the way across. So that total for one of my bases would be 4 plus times itself. 1, 2, let's see, 4 times 1, 2, 3, 4, 5, 6, 7, 8. So 4 times 8 is one of my bases. And that gives me 32. And then, so I'm going to plug that in. 4 times this one, we got 4, 4, 4, 4, 4. So that's 4 times 1, 2, 3, 4, 5. So that other base is 20. And then our height is a line that goes straight up and down to meet at a 90-degree angle with our bases. So now we got to count those blocks going up. So we've got, let's see, each one of these is 4. So 4, 4, 4, 4, 4. That's 1, 2, 3, 4, 5. So that's also 20 because 4 times 5 gives me 20. So the height is also 20. Okay, so just kind of keep track of that. Another way I could have done it was I could have counted the blocks and just wrote, I'll do it down here. 1, 2, 3, 4, 5, 6, 7, 8. That way I don't make sure I don't miscount my blocks. 8 times 4 times whatever the scale is gives me 32. Counting it this way, 1, 2, 3, 4, 5 blocks times 4 gives me 20. So just make sure you're kind of, whichever way works best for you, just make sure you're taking that scale into consideration. All right, so 1/2 times, first do what's in parentheses. 32 plus 20 gives me 52. 1/2 times 52 gives me 26. 26 times 20 gives me 520. So our area is, now they said this was square feet, so that means it is, area is feet squared. So the area of the pool equals that. Okay. Part B says, after the pool is installed, the community wants to put sod down. Sod is just already grass that's already grown and cut into rectangles. So they said they want to put, or squares, however they want to cut it. And you just buy it pre-grown and then you lay it on your yard. So it says, after the pool is installed, the community wants to put sod down on the remaining part inside the fence instead of the grass. So this is your fence all the way around here. Sorry. How much will the sod cost? Use math to explain how you determined your answer. So to figure out how much sod we're going to need, we need to know the area of this grass area, right? So since we've got these angles here from the pool and everything, that we don't want to just count up the squares and do it that way. What we can do is we can find the area of this whole big square or rectangle, whatever this ends up being, find the area of the whole thing, and since we already found the area of the pool, take this whole area and subtract the area of the pool, and that'll tell me how much grass or sod I need. So I'm going to take the area of the whole area. I'm going to write A for area and then explain this. This A represents the area of the whole space equals, minus the area of the pool, and that will give us the area for the grass, for the sod. Let me write sod instead of grass. Okay, so the area of the whole space minus the area of the pool leaves me left the area that I need to sod. So the area of the whole area, we got, let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So we've got a square here. It's 10 by 10. So the area of the square equals length times width. So 10 times 10 will get me that area. Just putting that over here. That gives me 100. The area of the pool we already found. Ignore that. Sorry, I'm making messes everywhere. So the area of the pool was 520. Oh, I made a little mistake. All right, there was 10 blocks by 10 blocks, but each one of those blocks is 4. So once I found this 10 by 10, that's not really 10 by 10. I hate when I do that. So really, this is 10 blocks times 4. So that's 40 times 10 blocks times 4. So 40. Multiplying 40 and 40, what's that give us? 1,600. Okay. See, I was able to fix it, not make it too horrible. So the area of the whole space was 1,600. The area of the pool, we said, was 520. 1,600 minus 520 gives me the area of the grass where we need to sod, so 1,080. So how much, the area that we need to sod is 1,080 square feet. Okay. Now it says if a strip of sod covers 1.75 square feet and costs $1.25 per strip, how much will the sod cost? So we take the area of the sod, the area that we need sodded, divided by how much one piece of sod covers, so that's 1.75. So this is the area of the whole area that needs to be sod, and this is the area of one piece of sod. So this will tell us how many pieces of sod we need. So 1,080 divided by 1.75 tells me we're going to need, I got a decimal, so 617.14. Now since I need this many pieces of sod, I can't just buy 0.14 piece of a sod. So what I really need is the number of sod pieces that I need is one more than that, just to make sure I have enough. So we need 618 pieces of sod, because if I got 617, we'd be short a little bit. There'd be a little dirt area that's not covered up. So we need to get 618 pieces of sod. Now that I know how many sod I need, I know how much they cost for each one. So the cost is going to be $1.25 times how many pieces I need, 618. So 1.25 times 618 gives me $772.50. And when it says explain using mathematics, you see all my math there. Boom. So I don't have to write out a paragraph or anything like that. You can see the math. All right, so the cost of sodding that area would be $772.50. Now I can guarantee you right now this will be on the test. This will possibly be on the quiz as well. So make sure you go back over this video again over and over until you truly understand what's going on here. Find the area of the pool. When they're asking for how much sod we're going to need, then you take the area of this whole fenced-in area, subtract the area of the pool, and you get how much sod or how much area we need to grass to put sod down. Once you got that area, you take that area divided by the area of one piece of sod, which they told us, 1.75 square feet. And when I divide that, that tells me how many pieces of sod I need. So I need 618 pieces of sod to go round up. And then 618 pieces of sod at $1.25 per strip. Multiply that out to get your cost. All right, that's a challenging problem. Next page. Trapezoid ABCD has base lengths of 10 units and 4 units. The area of the trapezoid is 39 square units. To the nearest tenth of a unit, tell me the height. So I draw my trapezoid. They tell me the bases are 4 and 10. Remember, your bases are your parallel sides. What we're trying to find is the height. Remember, the height has to make 90-degree angles with the bases. That's the side we're trying to find. They tell me that the area of the trapezoid is 39 square units. So I know I'm going to be using the area formula for a trapezoid, which is area equals 1/2 times base 1 plus base 2 times the height. plug in what we know. We know the area is 39, so we replace the A with 39. We know the bases are 4 and 10, so put those in for the two bases. And what we're trying to find is the height. So we just got to solve for that variable. Do your order of operations. Combine what's in the parentheses first. So that's 14. 1/2 times 14 is 7. And then to get h by itself, we just divide both sides by 7. And again, if I ever go too fast, pause, rewind, do what you got to do to get all your notes taken. 39 divided by 7 gives me 5.57, so we're going to round to 5.6. Yeah, because it said round to the nearest tenth. And since the units were just units, the height is 5.6 units. So it's just plug and chug. Figure out what formula you're using, plug in the things you know, solve for the thing you don't know. If the area of a triangle is 50 square centimeters, so I know I'm going to be using area formula for a triangle. So area of a triangle is 1/2 times base times height. I like to, since we're talking about a triangle, let's see. I'm just finishing reading. If the area of the triangle is 50 square centimeters and the length of one side of the triangle is 20 centimeters, what is the length of the altitude to that side? So when they say altitude to that side, they're saying the altitude is the height. Okay? Altitude, that means height. Okay? And when they say altitude to that side, so they told me one side was 20. They're saying the altitude to that side, or the height to that side, makes a 90-degree angle with that side. So here's the side that's 20, the height goes to that. So really, the base then is 20, and we're going to have to find that height. So the area they told me was 50 square centimeters, so we replace A with 50. We know our base is 20, and the height is what we're trying to find. So 1/2 of 20, or 1/2 times 20, is 10. To get h by itself, divide by 10, and we get that our height, or altitude, is 5 centimeters, because they told me the units were centimeters. And you're done. That's what they wanted to know. That's what we find. So all of this is just you getting the right formula, plug in what you know, draw your diagram to help you see it too, and then solve for what you don't know. Just looking ahead. All right, 2 more problems, and then it'll be closure and homework time. All right, the perimeter of a kite is 78 inches. Remember, perimeter is adding up all the outsides. All right, so I'm going to draw a kite because that's how I work. I need to see it. Okay, so there's my kite. The perimeter of the kite is 78 inches. If a short side of a kite is 14 inches, what is the length of a long side of a kite? All right, so we don't know the long sides. What we do know is on a kite, one of their properties is that their short sides are equal to each other. So that means this is 14, and their long sides are equal to each other. And so since I'm trying to find the long side, I just give it a variable. I know these both are x, these are both 14. Perimeter is just adding up all the sides. So perimeter equals 14 plus 14 plus x plus x. And they told me the perimeter was 78 inches. So I replaced the p with 78. Combine my like terms. Oops, let's combine those. 14 plus 14 gives me 28. X plus x gives me 2x. Because you just think of it as having a little 1 in front of those x's. All right, and that's just all about solving for that x. Get the x by itself. So we're going to subtract 28 from both sides. We get 50 equals 2x. Divide both sides by 2. You get x equals 25. They mentioned inches as their unit, so the long sides are 25 inches. . And there you go. I love that kind of problem. So you got to remember what you know about kites. Short sides are equal to each other. Long sides are equal to each other. If they tell you to find the long side, that's the side you don't know, give it a variable. Then what do you know about perimeter? That's just adding up all the sides. So set up your formula that way. Plug in what you know, solve for what you don't. All right. Last one, a rectangle has an area of 24 square meters. Since I'm talking about a rectangle, I'm going to immediately draw my rectangle. If the length and the width of the rectangle are whole numbers, we don't know what they are, what is the possible perimeter of the rectangle? So there's 4 correct answers they're saying here. We're going to try to figure out the possible lengths and widths to get us an area of 24 meters. Well, we know area for a rectangle is length times width. We know that they want us to just get whole numbers for our length and width. Okay? So we got to think, since the area is 24, we got to think of what whole numbers will multiply to give me 24. So think of your multiples of 24. We got 1 times 24. We got 2 times 12. 3 times 8. And 4 times 6. Those are my only whole numbers that will multiply to give me 24. So guess what? Those are my lengths and my widths for all of these. Okay, so they said there's 4 answers. 1, 2, 3, 4. So these are my possible heights and widths. So, okay, we're not done though. That just gives me the lengths and widths. What the question asks, that's why it's important to read them, what is the possible perimeter of the rectangle? They didn't ask for lengths and widths, they asked for the perimeter. So if these are my lengths and widths, I got to find the perimeter of these. So if I have a triangle where the lengths and widths are 24 and 1, then that means this is 24 and that's 1. Add up all the sides. Make a little chart, and I can guarantee there's going to be a problem like this on the quiz or test as well. Add up all the sides, 24 plus 1 plus 24 plus 1. That gives me 25. That gives me 25. Add them together, we get 50. 50 meters. All right. Now if I have one where it's 2 and 12. 2 plus 12 gives me 14. That's another 14. Gives me 28. Now we got one where it's 3 and 8. That gives me 11. That gives me 11. So add together gives me 22. And last but not least, 4 and 6. And you don't have to draw these diagrams each time. I'm just letting you see how it's happening here. 4 plus 6 gives me 10. 4 plus 6 gives me 10. 10 plus 10 gives me 20. So here are all my possible perimeters if the lengths and widths of this rectangle are whole numbers and their area is 24. All right, from here on out, I want you to do your closure, do your homework. I think it's a shorter homework assignment. It's just a quick one side of one page kind of thing. Do your best. When you're done, get it turned into the sub. If you don't get it done before the end of the period, then I will collect it next class. All right, have a wonderful day.